In this video, I'm going to go over Kirchhoff's laws, which just means Kirchhoff's current law, Kirchhoff's voltage law, and then I'm going to do an example that involves all of them. So first, we have Kirchhoff's current law, and you'll see that a lot of the time just written as KCL. And that states the sum of all currents into a node equals 0. And the way I prefer to use this is the sum of all currents in equals the sum of all the currents out. Like you can't make more current at a node. So if you look at this node right here, and we use this law, we say, okay, what's going in? We have an I1 going in, an I2 going in, and then it looks like an I3 going out and an I4 going out. So for this example, we would just say I1 plus I2, because those are going in, equals I3 plus I4. So that's how you do KCL. And then we have Kirchoff's voltage law, and you'll see that as KVL. And this one states that the sum of all voltages in a loop equals 0. So what I mean by loop is if we look at this, you just pick a direction, okay? I usually just go clockwise. It doesn't matter. You can go either way. And then you start anywhere. So I'm just going to start at V1. And what you do is you look at the terminal. So you can see V1 going clockwise. We're going to run into the positive terminal first. So that means if we follow KVL, we'll just say the voltage there, V1. And then next, we're going to run into the negative terminal of V2. So it'll be a minus V2. And then we continue following that, plus V3, minus V4, minus V5, and that will equal 0 according to KVL. So that's pretty simple. Now, how do you actually use these? Well, here we have an example, and this is going to involve both KVL, KCL, and some Ohm's law, so it's pretty involved. So how should we start? Well, in general, you want to look at a node that has currents you're dealing with and do KCL. So I'm looking at this top node right here, and we're trying to find V1, V2, V3, and I1, I2, I3. So if we look at this top node and then apply a KCL, we'll have sum of currents going in equals sum of currents going out. So we have an I1 going in equals an I2 plus an I3. And that's all you can do for KCL. Pretty simple. Now, if we do our KVL, we have two options here because see how we have two loops? We've got this loop and this loop. So what you're going to want to do is you're going to write in a direction. Again, I always go clockwise. You can go counterclockwise. It doesn't matter. And then you just apply your KVL. So I'm going to do the left one first. So I'm saying a negative 10 plus V1 plus V2 equals 0. And then if we do the other one, I see minus V2 plus V3 minus 6 equals 0. Okay, so those are Kirchoff's laws for this problem. So now we can apply Ohm's law. So how are we going to do that? We're just going to look at each resistor individually. So I'm going to say Ohm's law. Okay. So if you look at resistor 1, we can just say, because Ohm's law, V equals IR, right? So at resistor 1, we'll have V1 equals I1 times 2, because over here we've got an I1 going through resistor 1. Now we can just do the same exact thing for the other two. So then we're going to end up with V2 equals I2 times 8, and V3 equals I3 times 4. So now we're going to take a step back and see what we're trying to solve for. We're looking to first either find all the V's or all the I's, because if we know one, we can solve for the other. So I'm going to solve for all of the V's first. And to do that, I need 3 equations, because if we have 3 equations with 3 unknowns, we can solve for them. So I'm looking over here, okay, this is one equation that contains the voltages. This is a second equation that contains the voltages. Now I need one more. Now if I look at my KCL equation, I have I1 equals I2 plus I3. But if I can solve for I1, I2, and I3 in terms of voltages, I can get a third equation. So I'm just going to use the Ohm's laws to solve for that. So you can just say I1 is just equal to V1 over 2. I2 is just equal to V2 over 8. And I3 is equal to V3 over 4. Now, if we plug these into the KCL equation, we will get V1 over 2 equals V2 over 8 plus V3 over 4. And that will be our equation number 3. Now, this is 3 equations with 3 unknowns. So I'm not going to do all the algebra in this video. It's just going to be solve equations 1 through 3. And then you should end up with V1 equals 6 volts, V2 equals 4 volts, and V3 equals 10 volts. Now, I mean, you could use substitution, elimination, or you could plug it into your calculator and solve it using the matrix. That's what I like to do when I'm doing homework or whatever. It'll just be quicker. And you can't make simple mistakes. So now we have the voltages. That's half our answer. Now we need the currents. But if we take a look at these equations right here, since we have the voltages, we basically have the currents. So all we do is we plug in these voltages into here. So now I1 is going to equal V1 over 2, which is just 6 over 2 equals 3 amps. I2 equals V2 over 8 equals 4 over 8 equals 1/2 amps. And then I3 equals V3 over 4, which equals 10 over 4, which equals 5/2 amps. And that gives us all of the answers we wanted. So we're done.